Okay, so from the little bank of exercises that you have, I'm going to do question 1, question 3 and question 7. Okay, so question 1 says, a straight river is flowing at 1 metre per second parallel to its banks. So the velocity of the river is equal to 1. A boat heads straight across at 2 metres per second. So the VBR, he heads straight across at 2 metres per second. The river is 40 metres wide. How long will it take the boat to cross the river? Okay, now remember, the time to cross is the distance across, which is 40, divided by the velocity that takes you across the river. Now in this case, you can see your heading velocity just has a j component going across, it doesn't have any I components. So there's only one velocity taking you across the river here, so that's your VBR. So that's 40 over 2, and that's 20 seconds. The second part of the question says, how far downstream will it land? Okay, so its VBR is straight across. That means if the river's pushing it downstream, the VB, that's its actual velocity, that's where it's going to end up. So from where it starts here to where it finishes, that distance, x, would be the distance downstream. Okay, so to find distance downstream, x, remember, it's crossing time multiplied by speed. So x equals crossing time, t, multiplied by the speed downstream. So whatever speed takes it downstream. So in this case, the crossing time is 20 seconds. I'm going to multiply it by the speed that takes it downstream. Now there's only one vector taking it downstream, and that's VR. So I'm going to multiply that by VR. You never consider the VB, remember, the actual velocity. You ignore that, you only work with the VBR and the VR. So this is x equals 20 multiplied by, in this case, 1, so that's 20 meters downstream. Okay, so that's the first question, that's question 1. Now, let's look at question 3 on your question bank. It says a river is 60 meters wide and it flows at 3 meters per second parallel to its straight banks. Okay, let's quick sketch of what's going on here. 60 meters wide, and here it is. It's flowing, the river is flowing at 3 meters per second. So the VR is 3. A boat can go at 5 meters per second in still water. Right, now we haven't come across this expression yet, but it's very important. If you see in still water, that is referring to the relative velocity, the VBR. Okay, so the VBR in this case, it says is 5. So in still water is the relative velocity. Find the time the boat will take to cross by the quickest route. Okay, first thing, quickest route. Now, if it's going by the quickest route, that means it wants to, it's just going straight across. It doesn't care where it ends up. It's going to end up over here somewhere. We'll call that VB. It heads straight across. That's the VBR. Again, the VBR only has a J component this time because it's heading at 90 degrees to the bank. So the quickest route will be distance 60 divided by there's only one vector taking it across, and that's VBR. And we're told the VBR is 5. So this is 60 over 5, and that's 12 seconds. Okay, so that's the quickest route. The second one says, find the time it takes the boat to cross by the shortest route. Now, the shortest route, let's draw that river again. It's still 60 meters wide. Here's the boat. By the shortest route, that means it wants to end up directly across from where it starts. It doesn't want to travel upstream or downstream. So in order to do that, it's going to have to head up in that direction. It's going to have to head upstream. So that's the VBR. Of course, the river is going to push it downstream. So the river is acting in that direction, VR, and of course that's 3. Okay, so by the shortest route, what's the crossing time? The time is equal to 60 over. Now, I have to do a bit of work. The VBR is going to be made up of two components. Remember, it only had a J component in the quickest route, but this time I'm going to break it into its two components. That's the angle it makes to the bank, theta. This one is VBR cos theta, and this one, of course, is VBR sine theta. Okay, the one that takes it across the river is the VBR sine theta. So that's 60 over VBR sine theta. Right, the VBR sine theta is 60 over, VBR of course we know is 5, so your job is to find the sine of theta. So let's see what we have. What we do have is a triangle. So I'm going to draw this triangle here. Remember, this is the angle it makes to the river bank, that's theta. Okay, so this is the crossing triangle. This is the VBR, this is the VR. The VBR I know is 5, the VR is 3. The VBR sine theta I don't know yet. But I can see that this is a right angle triangle, of course. And, you know, if I use my ratios, I can use Pythagoras here, and so the square on the hypotenuse is the sum of the square on the other two sides. That means this has to be 4. So the sine of theta, by the alternate rule, I could get that theta in here. Okay, so the cos of theta is 3/5, the sine of theta is 4/5, and I'm after the sine of theta. So my crossing time in this case is t is equal to 60 over 5 times the sine of theta. Opposite over hypotenuse, 4/5. Those 5, of course, will cancel. So it's really 60 over 4, which is 15 seconds. So it takes 15 seconds to cross in that particular case. Now the next one I'm going to have a look at is number 7. Number 7 is a straight river is 58 meters wide. It flows with a speed of 2.1 meters per second. A boat can travel at 2.9 meters per second in still water. Okay, so let's get that information into a diagram. So we have a river. It's 58 meters across. We know the velocity of the river is 2.1 heading downstream. And we know that the VBR, we're told that the VBR is 2.9. And how do I know that? Because it tells me in the question, a boat can travel in still water. So this is your still water reference. Remember, if you see that, it's relative velocity. Okay, first part of the question says, if the boat crosses by the quickest route, how far downstream will it land? Okay, so if it's crossing by the quickest route, doesn't care where it ends up, it just heads straight across. So the VBR doesn't care where it ends up, it's going to end up down there somewhere. That's the actual velocity, the VB. Okay, so if it, the question says, how far downstream will it land? So if this is the situation, it starts here, and if it ends up over there, it's going to end up X meters downstream. So your job is to find X. Okay, so your distance downstream, your X, is equal to crossing time, T, multiplied by the velocity which will take it downstream. Now, what velocities are going to take it downstream? There's only one, the river one, because the VBR is only made up of one component, the J component, and that's just taking it across. So it's not taking it up or downstream. So my distance downstream X will be crossing time T multiplied by the velocity that takes it downstream, 2.1. Okay, so let's find the crossing time. The crossing time T is what? Crossing time T is distance divided by VBR sine theta, which in this case is 58 over the VBR is 2.9 by the sine of theta, which of course is just sine of 90, which is 1. So this is 58 over 2.9 by the sine of theta, which in this particular case is just 20. Okay, so 20 seconds. X is equal to, therefore, distance downstream is time, which is 20, multiplied by 2.1. In this particular case, then, it's 42 metres downstream. That's how far downstream it will land. Now, the second part of that question says, same river, if this boat crosses by the shortest route, how long does the crossing take? Okay, so let's get rid of this. Same river, it's 58 metres wide. We still have that river velocity, VR, 2.1. Let me just see, where am I? Okay, so we know that the VBR is still going to be 2.9. Right, crosses by the shortest route this time. Okay, so if it crosses by the shortest route, it wants to go straight across. So here it is, it wants to end up here. That's where it wants to be, which means it's going to head up there in that direction, VBR. Okay. How long does it take to cross in this particular case? Okay, now remember that VBR is made up of two components. There's an angle to the bank, theta, and this is going to be VBR cos theta, and this, of course, is VBR sine theta. So the crossing time in this particular case is T is equal to distance across, which is 58, divided by VBR, which velocity takes it across the river? VBR sine theta. I know what the VBR is. It's 2.9, so this is 58 over 2.9 sine theta. So your job is to find sine theta. So let's see, what do we know? Let's take this crossing triangle here. I'm going to draw, it's a right angle triangle. The VBR, of course, is 2.1. The VR is 2.1. The river velocity is 2.1. The VBR, of course, is 2.9. And this is the angle that the VBR makes with the bank. And if I use the alternate rule, I can bring that theta in here. Okay, so I know, therefore, that the cos of theta is equal to adjacent over hypotenuse, 2.1 over 2.9. That gives me a theta of, second function cos 2.1 over 2.9 is 43.6 degrees. Okay, so my crossing time, T, is equal to 58 divided by 2.9 by the sine of 43.6. And when I do that, I'll get 58 over 2. So that gives me 29 seconds to cross.